So we're very lucky to have Joel Becker today giving a guest lecture. I'm not sure if there has been any. I'm not sure if there has been any lecture in this course where I've not shown this METR graph of like the time horizons. And probably if I didn't show that graph, I showed something else of it that METR is doing. So they're really doing a lot of great work. And before we start, just some administrative things. I will not do my usual office hours usually I do them in Swiss Bakers at 9 a.m. on Fridays. This time I'll do it after lecture. We don't have an experiment this lecture unless someone can correct me. So I think we might finish earlier. So then if we do, then we'll just have like the office hours. Like I'll just stay around here and talk to people, whoever wants to talk to me. And yeah, the mini project, if you didn't yet fill in like who you're working in the topic, do that ASAP. And the last lecture of this course, I just realized that, like actually today, I always thought it was on December 4th, but then I realized that the semester actually ends on December 3rd. So, and the November 27th is Thanksgiving, so the last lecture is November 20th. The mini project, we extended the deadline till November 2nd. But if you can already start on the final project, you might as well do so, because the deadline for or at least find out who your group is, and we'll post more details on the final project soon. But the deadline for the final project will be the last day of the semester, December 3rd. And the way we will do it is we will, after you submit the final project, we will go over them and we will, I think just going through a marathon of final project presentations could be really hard. So what we'll do is the TAs and I will pick a few projects for oral presentations, and we'll also do like a poster session for all projects. And we'll find a good time to do that in the exam period. So we will figure out like a good time to do that during the exam period. And with that, let me pass it over to Joel. Bring yours. That's the best.
Can everyone hear me? Do I need to make sure my mic is on?
Yes, please do, because we record it.
Cool. How do I do that?
I should don't like it. Yes, now it should.
Wonderful. Okay. Thank you very much for having me. Very excited to be here with you all. I'm Joel. I work as a researcher at METR. I'm going to be talking to you today about a puzzle. There are these two sources of evidence that we have about capabilities. Plausibly there are more, but there are at least two buckets. I'm going to claim one is this benchmark style evidence, the kind of thing that you see on the METR graph, the kind of thing that you see reported on the model cards put out by various companies. And then another is kind of in the wild capabilities. So either like impacts that we see on the economy today, or RCTs that people run, these messier, sort of more on the ground, also sort of more holistic, maybe more like getting at some final thing that we care about. Source of evidence, they seem to be giving some different answers. I'm going to be trying to reconcile those different answers with you all. I work at METR. I guess you've seen the graph. Okay, under lab-like evidence, we're going to be going through benchmarks that you guys are all aware of. This paper that I worked on with the graph that you're all aware of, GDP val, which I think came up in the reading. And then as far as field-like evidence goes, we're going to be going through this paper that I was co-lead author on, and a little bit of labour market data, although I gather you'll be talking more about that later in the course. We'll try to reconcile them. We'll give some implications for the labour market, possible technological unemployment, and automating AI R&D. You might have heard of METR. Stands for Model Evaluation and Threat Research. Model evaluation, that is, we ask how capable are the models, what might be the propensities of models, or at least agents based on these models. And then threat research, we try to sort of tie this understanding of capabilities and perhaps propensities of these agents to threat models that we have in mind, going through some sabotage-like channel or AR&D automation or something like that. Maybe this is too dumb a question to ask, but I thought I would do a little bit of motivating. Why do we care about AI capabilities? At least why do I care about AI capabilities from a METR standpoint? This is I think, greatly underread resource. Many of you have seen the graph. I think most of you, unless it was in reading at least possibly before the past week, would not have seen METR's GPT-5 report. It's not quite like some of METR's entries on the model cards that you might have seen previously. These documents from the companies listing the kind of safety testing that they did as part of the model release and what METR's contribution to that was. Instead, it's METR trying to make a sort of structured argument for GPT-5 posing catastrophic risks to society or not, as the case may be. This is very roughly the shape of the case. We've got a couple of threat models at the top, AI R&D automation, autonomous replication, and the possibility of sabotaging an AI company. We have some sources of evidence. The first is sort of promises or assurances from the AI lab, in this case OpenAI for GPT-5, some measurements of GPT-5's capabilities, and then some examining of reasoning traces. What to say about this? One reason why we're interested in bringing in reasoning traces and assurances from the lab is that we want to have confidence that the model is not sandbagging, that is sort of understating its own capabilities, and so we can really rely on our capability assessment. In part because much of the reason we come to this conclusion that it's very unlikely that GPT-5 poses a catastrophic risk is that we think it's not capable of some of the things it would need to do in order to pose a catastrophic risk. If we were severely underestimating those capabilities for some reason, perhaps, for example, because perhaps it was sandbagging, that would seem to undermine our case. Okay, we're going to be talking about the capabilities components in particular. This is what's motivating my care for AI capabilities. How do we measure this? At least, what's the most popular way of measuring AI capabilities? Probably today, but also, in particular before this year. Well, you have a series of benchmarks. Here are some older benchmarks. They often have some human baseline. They often have some score between 0% or 100%, some maximum that you can possibly achieve on the benchmark. It's a little bit difficult to interpret some of the data points here, some of the lines on the graph. Is getting to 100% of the human baseline, does that suggest superhuman capabilities in some relevant sense that we care about? What does 80% raw score, 60% raw score mean on SWE-bench? It's a little difficult to interpret. Another thing that jumps out at me here is that the pace from which we go from zero signal on these benchmarks to total saturation of these benchmarks seems to be decreasing over time. It's extremely difficult today to create benchmarks that are not already saturated. Here are some more recent benchmarks. This is data from Epoch AI. I don't know. The AIs are getting better according to benchmarks. Here in the METR paper is what we're going to do instead. Slightly different take on the problem, although it does have a lot of similar attributes. I want to quickly say, if anyone has aggressive questions, please shout at me at any time. We don't have to wait till the end. Roughly the idea is that we're going to calculate a bunch of human times to complete some set of tasks under as close as possible to identical conditions to the conditions under which AI agents are going to be asked to complete the task. That is sort of same sort of environment, same kind of access to commands, so on and so forth, same resources. We're going to measure AI performance on those same tasks, and then we're going to convert the human time to complete into an estimate of autonomous AI capabilities. To go through that a little bit more, here are some example tasks. should I jump back? No, I'll stick with this one for now. So first, actually, I will jump back. So the HCAST benchmark that you see at the top left here is a collection of tasks that are quite open-ended, that seem to require a lot of autonomy in order to complete, or at least seem sort of indicative of autonomous capabilities. They're all computer-based. They're all software-based. The SWAA benchmark is this series of atomic software tasks. These are tasks like, here's a list of 4 file names. One of them's passwords.txt. Which file is most likely to contain the passwords? And then REbench are these much more challenging set of machine learning research engineering tasks. These are tasks like, what's a good example? Here's a big fine-tuning script. Can you get to exactly the same functionality whilst causing the script to run in much less time? Or like, can you optimize this kernel? These kind of challenges. And then from that, for each agent, we're going to get a chart like this. In the purple bars, you see success rates by bins of human completion time. So what do we have? Something like 60% success for Claude 3.7 Sonnet in the 1 to 2 hour bin. We're going to fit a logistic regression over, we're going to fit a logistic curve over these success rates by task difficulty. And then we're going to call the time horizon of this model the point on the x-axis at which we think it's a coin flip whether the model would be successful at this task or not. There's nothing special about 50%. There's a little special about 50%. Maybe it's the point at which we're maybe best powered because we have the most positive and negative examples. It's a point, a coin flip that feels quite intuitive. It's consistent with previous literature, but there's no fundamental reason we're choosing 50%. If you think this is fishy, you should think this is fishy. Please keep that in mind.
So Joel, the question, how typical is this graph? What's I find kind of interesting is that the human duration is so predictive of model success in the sense that, say, there is a sense in which up to 4 minutes, basically the model succeeds 100% of the time. Is it something about these particular benchmarks, or is this something that you see generally?
Great question. So it definitely is an empirical observation, and I'm not sure we have great sort of a priori theoretical reasons to expect this to be the case. I do think it's an empirical observation that's borne out in many places. There is, I can't remember exactly where it is. It's possible it's in the GPT-5 model card. I have seen somewhere some data that suggests that on some benchmark, longer tasks, AIs are as performant on longer tasks on this benchmark as they are on shorter tasks on this benchmark. My guess is there's some sort of complicated distributional differences between the long tasks and the short tasks in that case. I do think this is a empirical regularity. It's not more than that, but I think it's an empirical regularity.
You have not observed, so you could have kind of potentially observed kind of bottlenecked short tasks that somehow tasks that humans only take a minute to do, but somehow models, no matter what, they cannot do them. But you don't seem to have observed that.
Yeah. One thing that we're going to see is that this measure is going to be, in some ways and not in other ways, sensitive to task distribution. And you might think that these atomic tasks are not from the same distribution in the relevant sense, and that's part of what causes this pattern. That seems not so implausible to me. But yes, for the most part, I feel reasonable calling these things sort of distributionally similar. Some are shorter, some are longer. It turns out for the shorter ones, the most modern models are really excellent at the shorter tasks. Yeah.
So we read the METR's evaluation on GPT-5 as well, and one thing that I was wondering is clearly you guys have ways of quantifying this type of capability stuff in a way that presumably was not done before. One thing that stood out to me on the GPT-5 evaluation was that many times it seemed to me that certain things were identified, and then it would just be a one-line explanation of, but we discussed it internally and thought that it wasn't worth caring about, and then you move on to a different topic. I was wondering why you went to the route of like not trying to find like maybe quantify that, report that, like the quantified ways of doing it. And was this like due to time constraints? Did you internally use like a quantified method and then just not report that? Like how was it going on?
Yeah, great question. I worked on the papers. I didn't work on the GPT-5 report. Important caveat. My strong guess would be that there's like very limited time. METR is a small team. The size of the technical staff is, I'm not exactly sure, it's maybe 15 or a little bit more. And also, I think we've made great progress on the science of evals, but like there's a lot left to be explored. To the extent that there are those sorts of things that appear, I'd guess it's either a matter of the science isn't in, or the science is in, but we didn't have time. The one prominent example that I'm aware of is, a bar that we set for capabilities that we think might be dangerous is having a 40-hour time horizon at 50% reliability. Where does that number come from? It comes from, Hjalmar, a bit of a genius, smartest, one of the smartest people at METR, one of the smartest people I know. It comes from a guess that he pulled out of nowhere. If you have like better ideas for where bars should be set on capabilities, I'm extremely open to them. But sometimes that is the kind of thing that we need to resort to. Yep.
Sorry, this is maybe two slightly related questions. One is why is this like logistic? Why is it reasonable to assume it's logistic with respect to log of time? Two is, are the 4-hour or 2-day tasks just like 2,000 times like a 1 second? Like can these long tasks be decomposed into short tasks? And like naively, you can construct tasks with arbitrary length by just concatenating tasks which sequentially depend on each other and then have like smaller length. And I assume that this is not what we actually care about. So I guess in what sense are the longer tasks more difficult because they are just from a different distribution versus like how, I guess another thing is like how hard is it for models to find the intermediate steps? Like it's possible that longer tasks can be decomposed, but the hard part is to like find the way to decompose them. I don't know which. Yeah.
Great. Let's take the first one first. Why do we use logistic? I don't know. I like look at the histograms. I'm like, that's not the only reason. We could be using a probit. We could be using some like piecewise local linear thing. I think they're going to be, at least for the 50% point, they're going to be giving us pretty similar answers. If we were trying to measure 99% reliability, then the distributional assumptions are going to change maybe quite a bit. The summary statistic that comes out. Logistic regression, I think, is what's used in the literature that we appeal to, this IRT literature from psychometrics. Those are some justifications. I leave it up to you to sort of think those are reasonable justifications or not. As far as the... How should I best answer this? So you've seen the chart. There are two different sort of time axes here. There's like calendar time. There's there's like sort of some notion of the time it takes humans. There's also a third notion of time that you might have in mind and that I'd be careful not to conflate with these two other notions of time, which is the time that models spend completing the tasks. I think it would be helpful if in your head to a first approximation, you just set that to 0. They're like not quite instantly answering. Some of these things are going to require sequential actions, but that's not the main thing that you should have in mind here. Related to that, this time horizon measure is, collapsing both some notion of difficulty per step, maybe. So maybe some types of problems only require one step, but they're much more challenging. So you need to, think for longer. Or if you're a human, you would want to decompose it into a sort of chain of thoughts. Think about it for longer, and like necessarily having a sequential sequence of actions that you need to take. It's collapsing that into one measure, which is something like human time to complete. You could create longer tasks by concatenating smaller tasks. At least, given that we've not done that, there are going to be some types of tasks that are sort of subsettable into these smaller tasks, and some that are not. Indeed, I think some of the HCAS tasks are sort of strict subsets of one another. There's like, can you find these 10 bugs in this piece of software versus can you find 3 of those 10 bugs in this piece of software? And we deal with that in a way that you can see in the paper. Yeah, can you hit me again? What feels unsatisfying about that?
I don't know. I just don't really know the tasks that I guess you answer.
Yeah. I think you should think that within this summary statistic, there are a bunch of different dimensions that are interesting. I'm obscuring those dimensions in some sense. That there are interesting questions to be asked inside those dimensions.
And Joel, also maybe like actually your two answers are related to each other. Like empirically, say if you go back to this logistic fit, empirically you have seen that it's somehow you get a good fit for like a logistic function when the x-axis is log of time. Now maybe I'm wrong, but I think that if the tasks were just concatenations of smaller time, it would have not have been log of time, because then basically if you succeed with say probability half and the task would basically, a task of 4 hours would be basically 4 tasks of 1 hour, then it should have been like something like 2 to the minus 4. So maybe the fit should have been different.
Although then you'd get this like exponential drop off.
Yes, right. Because if it was truly the case that like a 4-hour task is, or like a 16-hour task is basically 16, you do 16 1-hour tasks, one after the other, then the probability should have been 2 to the minus 16. So maybe it would have been like a different distribution.
Yeah. I think there's something here. I feel not on top of the maths. There's this. If you go on Toby Ord's website, he has this. He has this post suggesting that one model that would fit the metadata extremely well is to consider each model as having a sort of hazard rate, so some chance that it fails at some step each period of time. And my impression is that you can recover something like these fits from something like that model. But yeah, again, I feel not on top of the details there. There's another question.
Yeah, when it comes to interpreting the success probability, is it closer, like let's say the 50% success rate, is it closer to say that 50% of the task is completed 100% of the time? Or is it given any task in that time range, there's a 50% chance of it completed? If you understand what I mean.
Yeah. One of my closest collaborators at METR is this guy called Nate Rush. I think possibly after this lecture he'll watch back the lecture. So I kind of want to give a shout out to him. His impression is that I'm supposed to be working on that question this week. I'm currently not sure exactly what the answer is. Yep.
I mean, just to be clear, you are this probability is taken over both sampling a task and sampling multiple rollouts for each task. And in particular, when it's 100%, it's 100%, right? So if it's 100%, it's 100% of the task and 100% on each task. Only when it's 50%, it basically could be either like on 100% of the task you do 50% of the time, or like on 50% of them you do 100% and on 50% you do 0.
Yep. Yeah.
This is about the task specifications again a little bit, and I'm sorry if this was detailed further, and I just forgot it, but for the task specifications, do you take into account the time necessary to create the context for humans as well? In that, like, for many different tasks, it just comes down to getting enough context, and then it's like, quick, right?
That's a fantastic question. I'm gonna skip over that question because I want to discuss it later.
Oh, okay.
All the way back.
Sorry, when you're like reporting the human times, does that mean like the time it takes humans to get 100% success rate on these tasks, or?
Yes. So we're going to call success not necessarily 100% on some underlying metric, but for some tasks they're defined such that success is 1, failure is 0. For some, there's some underlying metric, maybe between 0 and 1, and we're going to binarize success on those tasks by setting some threshold like 0.8. The same would apply to the humans. It would be the geometric average time that successful human baseliners took taking this task and getting above the threshold.
Okay.
Again, like with the 40 hours, 50% reliability being some dangerous capabilities threshold. Notice that there's a lot of arbitrariness here. We could take different thresholds. Different thresholds would probably correspond to different lengths of time that humans would take to complete to get that threshold. These are some of the skeletons hidden in the closet. Cool. So we've seen this graph, generalizing the thing that we saw for 3.7 Sonnet to a bunch of other models. The logistic fit is like maybe reasonable, sort of, across a bunch of these models. The time horizon is the point on the x-axis at which we predict success probability to be 50%, and then if you plot that over calendar time, you see something that kind of looks exponential. You've already seen the graph. It does look extremely exponential on this log linear plot. Then we try to explore. We try to attack this conclusion. Is sort of what's happening in the rest of the paper. Maybe let me do a little bit of storytelling about what's happening internally. There's this chart from a METR internal presentation in like early 2023. Where can I draw on the whiteboard? Where on some y-axis is written not exactly, but roughly some sort of dangerous capability measure. And then here is like time or compute or other resources or whatever. And the graph looks roughly like this. That is, we were from an early stage trying to go for some sort of trend that was predictable, that was forecastable, that would allow us to say. Allow us to give informed forecasts about some next model that we'd not seen before, or some capabilities level that we'd see at some point in time. And like, of course, we were doing this messy thing. Like the process for creating these tasks is like people come to us with their tasks, and we try and make those tasks more robust, make sure the models can't easily cheat on them. They have fair scoring criteria. They're fair for the models versus humans. They're completable, sort of only using only with access to a terminal and the relevant commands, etc., etc. Some internal tasks were created by METR staff, which is just staff like brainstorming. What would be difficult for a model to do, or like what's a challenging R&D problem that we've not seen on the internet before. It feels very messy, and so obviously when we go about and produce this graph, it's going to have this pretty low correlation with whatever the x-axis is. It's not at all going to look like this graph. When we saw this graph, we were I'm not sure jubilated or suspicious or like assume something's gone wrong. It's, something in this direction. It's kind of it's weird that the fit is so tight. So we try and attack that conclusion for the rest of the paper. One thing is if you kind of naively and very irresponsibly extrapolate to 1 month, 50% time horizon, then you get something like 2029 to 2030 on the main trend. Or if you notice that these recent data points look like they're rising a little bit faster, then you might think 2027, a famous date, is when 1 month, 50% time horizon arrives. I'll give off-the-cuff opinion is that some of my colleagues share and some of them don't. I think when you have so few data points, it's kind of irresponsible to add extra parameters or something. You should go for like the most parsimonious fit you possibly can. Here, the most parsimonious fit is just like the one straight line. I'm nervous that having the 2 straight lines is reading the tea leaves a little bit too much. So I personally would be sticking to this 2029 to 2030 sort of thing. Okay, and then here are some attacks on the conclusion. The first is, well, if these logistic fits had very different slopes per model, then maybe you'd end up with trends at different reliability levels that looked sort of much less clean than this 50% trend. It seems like that's not the case, at least for the 80% reliability level, and therefore I think the 20% reliability level. We do some checks for external validity. That is, we feel reasonably good that we've got internal validity down, that we haven't made mistakes in our statistics, that we basically believe in the tasks, the procedure that we're doing, the summary statistics, that we're generating. But to what extent does this apply to the real world? Here are some things we do to check. The first is a retrodiction exercise. When we first were going about implementing that chart, we didn't have this atomic actions suite. The thing with the passwords.txt is in this list of files, which file contains the passwords. We only had these more challenging tasks. And so, because GPT-2 is not able to do novel machine learning research engineering, we weren't able to measure GPT-2 on our task suite. So you might ask, well, given what we had at the beginning, how well does this predict the rest of the trends? And the answer, it seems, is surprisingly well. It would fit. One thing I was thinking about this week is that for all of these points, we're using announcement date as the calendar date, except for GPT-2, where we're using, because OpenAI delayed the release of GPT-2 for a long time, we're using the announcement date rather than the deployment date, where we're using deployment date for all of the other data points. That would move GPT-2 to late 2019 and then make the fit of this retrodicting exercise even stronger. One question is if there's, which we'll come back to, is if there's something weird and unusual about the task suite, in particular the fact that the METR tasks, like many benchmark-style tasks, are not messy. That is, they don't involve a lot of interaction with the real world. They don't have kind of highly ambiguous scoring criteria. They're nicely packaged. The context has been curated for you. All this sort of thing. There is, for the most part, I would say basically all of the METR tasks, like basically all benchmark style tasks, are on the very low messiness range. But there is a little bit of variation, even though they're all kind of lower on the range. So you might ask, do we see this trend of increasing performance on even the messier tasks within the range, which you should think of as being sort of middle messiness tasks or something, not actually high messiness. A non-exponential trend on this measure does not imply a non-exponential trend on the other measure, because the y-axis here is success rates rather than time horizon. But broadly, we find something consistent with progress going up on the messier tasks as well. This is an external validity check because we think that real tasks in the world are likely to be more messy than METR tasks.
This says least messy, not most messy.
Sorry, that's the least messy tasks, and those are the most messy tasks. Thank you very much. I will note again that this concern about the task distribution, not being messy, is not at all idiosyncratic to the METR tasks. This is true for many of your, is it true for all of your favorite benchmarks? That can't be true, but it's true for many of your favorite benchmarks. For example, SWE-bench, which has other issues that some of you might be familiar with. For example, contamination, some of the problems being impossible. It also has this feature of to succeed on SWE-bench tasks, you need to pass algorithmically scored unit test cases. So both the quality of code or the quality of output you have doesn't matter. The only thing that matters is do you pass the test cases, or at least some more holistic sense of the quality of your output doesn't matter. And also the problems have been selected to be the kinds of problems for which we can do this algorithmic scoring. And another external validity check, sort of with the previous caveat that we see something like the same trend on SWE-bench verified. This is just a different data set, suggesting there's not something totally weird about the METR task in particular. Here the doubling time is 70 days, which I think when's this? That goes to.
That's a huge difference.
Yeah. Are we already at 1 month AGI by that? I think this is probably a problem with the human baseline times in SWE-bench that's generating this much faster doubling time. Okay, in more recent work, first we've continued to compute the time horizon measurements for models as they come out. This, you note that the dotted trend is starting from Sonnet 3.7. That is, we're only fitting the predictions from the models that you saw on the previous graph, the models that were out at the time that the paper came out. The predictions have the implied predictions from that curve seem to have been reasonably good. They're consistent with this faster slope, although very very opinionated. I still feel like we should be nervous to have less parsimonious expectations around the shape of this curve. Some other recent work from my colleague Thomas Quah shows using a slightly different method to get the time horizons. It's a method that's using, I think, implicitly lower quality human baselines. There's a bunch of things about this you can see more on the METR website that are not directly analogous to the previous work, but it's trying to do a similar exercise. And I think the suggestion of this graph, or my read on this graph, is that the slopes that we see, the doubling times in time horizon across quite different task distributions. These are still all sort of software-based tasks. That's important. But across different kinds of software-based task distributions, are surprisingly to me similar to one another, but the intercepts are very different. That is, we're starting from a lower point on, especially tasks that require a great deal of vision capabilities. Yeah.
So this was a little behind, but I just have been thinking about it. For the messiness plots, why did you choose accuracy rather than like expert?
Because there are even fewer than 15 technical staff at the time, and we need to get the paper out there.
Okay.
That's the real reason.
That was reason.
I think I'm pretty sure that's the real reason.
There's also a question over there.
Yeah, sorry.
I had a quick question. So you guys showed like the recent models with GPT-5 and such. Have you benchmarked and or tested Anthropic's claims that 4.5 could like work for 30 hours on its own on a task?
So I'm not sure I understand exactly what Anthropic are trying to claim there. I note that us estimating something like 2-hour time horizon of Sonnet 4.5 is totally consistent with there exists a case where it's working coherently for 30 hours. This is more like an average type of thing, and that's more like a maximum type of claim.
These are completely different things. Like there is the length of time it would take a human to do the task,
Right.
and the length of time it takes the model to do the task. Now, presumably, it does seem like if the model is working for 30 hours, then it would be kind of surprising if a human could do it in 2 hours. But it's not completely. It's not necessarily impossible, but also like maybe the worst case versus average case.
Yeah.
Or best case.
Yeah. That seems right to me. Cool. Next up on the benchmark side of the capabilities landscape. What time am I at? I'm doing okay. Is GDP val? This is not my paper. I might get stuff wrong. There's been a lot of excitement around this paper. I'm going to give some opinionated takes on where I share excitement and where I feel like it deviates less than you might expect from previous benchmark work. Here's roughly what they're going to do. They're going to select for the 9 most common sectors, the 9 sectors that contribute the most to US GDP, the 5 occupations within those sectors that contribute most to wages and compensation in those sectors and are predominantly digital. Notice again, predominantly digital. There's some important selection going on here. This is something like what the occupations look like. And then for each occupation, they are going to get experts or professionals in those occupations to help them create tasks. That is a pair of curated prompts and task context, as mentioned earlier, and some experienced human deliverable against which we can compare the AI deliverables. Notice that these deliverables are not only text-based. I think that is an important improvement. And then here's how they're going to score things. They're going to get a response from, in this instance, GPT-5, although there are a bunch of other models that they report in the paper. They're going to have the human gold standard deliverable that we just spoke about that comes with the task context, which we see at the top, and the reference files attached to that context. And then they're going to ask, in one case, another group of human experts, and in another case, a sort of LLM as judge, a kind of automated grader, which I think they stand by less, to rate according to some subjective and objective criteria which deliverable is superior. And then this is what they find. I think I heard it mentioned in the room earlier that it's impressive that they note a non-OpenAI model performing better than OpenAI models on this benchmark. I think that's commendable research practice. Yeah. Do I want to step back and ask what this means? For now, I'll say I don't know. This looks pretty impressive. Here's my list of opinionated pros about this benchmark. Firstly, something that we're going to dive into later is that my sense is not a hugely quantitative importance consideration, but a quantitatively somewhat important consideration when thinking about the success rates that models have on benchmarks is this algorithmic scoring piece. That is, we score the AIs using this sort of zero marginal cost, automatic, only checking sort of some subset of what you really care about scoring procedures. But we could do something else, where humans rate in an instance that we're about to see whether some code would be merged into main, given holistically the quality of that code, not merely whether it passes some test cases, or here whether some sample response is superior on some list of subjective and objective criteria. I think that's important and impressive. I think we'll see more of this going forwards. The second is long horizon difficulty. It's, I'm thinking this week, last week, next week about how to get more challenging tasks so that if you look at this diagram, you'll note that there are not so many doublings to go before we are not able to measure 50% time horizon reliably. It's very, very difficult to find in the wild tasks that we think take humans more than a day and are not sort of insanely expensive to generate. So it's a serious pro from my perspective that some of these tasks do seem to take humans a very long time. And the next is task realism. My impression from the paper is that these do correspond to real work outputs in occupations that contribute some important fraction to US GDP. Okay. On the other hand, here are some opinionated cons. The first is that, I think this is related to the curated context thing. The first is that by taskifying or by bringing things into a benchmark in this way, I feel that you remove some real world frictions that in some sense advantage the AIs. You're only judging final outputs. You're not doing this thing where you yourself as the worker are trying to define what the task is, and then you give a sort of intermediate output to your boss or colleague, and then integrate that feedback into a final output. Reason about, is this even like the thing that you're supposed to be doing instead of some other thing, given what your high level goals were? Are the high level goals wrong? All of this sort of thing. A second, curating context for the model. Information retrieval is an important part of work, and there's some extent to which that is featured here, but I think there are some senses in which this is underplayed in GDP-val and in other benchmark style evaluations. And the last is ignoring dependency across or interactions between tasks. I'm not exactly sure what to say about this. Maybe I mean something like, suppose there are two tasks, A and B, and completing task A yourself is important for completing task B. Like having worked through the problem, or like having seen the solution or something for task A is important for task B. And let's say the models can do, task A but not task B. No, I think I've gone a little. I think I've confused myself there. Anyway, I think there might be important interactions between tasks, such that testing on a task by task level, in some sense, advantages the models. Here's what they say about this in GDP-val. Actually, let's skip over that. And I had skipped over this other opinionated con. I think there's selection for the kinds of tasks that are scoreable by low context judges. I think this comes out of taskification. The experts are curating tasks that they think will be in principle scoreable in the benchmark by judges that are not sort of intimately familiar with the work previously, even if they are in the relevant profession. Okay. Then taking a quick step back. What do benchmarks tell us? I'm about to say a bunch of more bearish things about AI capabilities today. I think we, I think it's important to step back, look at the kinds of machine learning challenges that make up RE-bench, this METR benchmark. You can read that paper separately. I would totally fail to complete any of those challenges to the standards of AIs today. That seems to me like a kind of extraordinary fact that AIs are so capable of such technically difficult work. And I think that progress is rapid. This won't be news to you. But we're about to introduce some caveats to that. Here are some limitations. One is that the baseliners, or in GDP-val, probably the human expert judges, are low context. This is not directly the work they're doing every day. If you work at METR, you have extra context on METR tasks that allows you to complete things differently, faster than if you were an expert software engineer or an expert research engineer or something, but were not intimately familiar with the METR stack. Another is the ceiling is fairly low. A lot of these benchmarks are getting saturated. The tasks, I think, are highly selected in some important sense, as we just went through. And messiness, not quite necessarily the benchmark style tasks aren't messy, but it's very expensive to produce messy tasks. So in practice, if you're looking for something close to what you care about and scalable, you often sort of sacrifice messiness as a desiderata.
One thing that I was wondering were your opinions on maybe using a different subset of economically valuable tasks. One thing I was considering while reading the paper was thinking about maybe freelancer/contractor work, where there's inherently lower context provided in the specific tasks that are asked, but it's still economically valuable. And it could also be organically measured by just having the models complete legitimate, like freelancer contractor work, and then telling the people afterwards, actually, you don't have to pay us this or whatever.
There's a benchmark called Sweelancer, which does this, and you should search. Mm-hmm. I think it's a good prompt. Okay, perhaps field experiments are part of the answer to the limitations of benchmarks. They're going to have a bunch of cons, but I think also some complementary pros. In the particular field experiments that we're going to discuss today, the one that I helped lead, we're going to be using extremely high context developers. The tasks are going to be not synthetic. These are tasks that would otherwise come up in the real work of these developers. And there's some sense in which we could get signal through the superhuman range. Once all of the benchmarks are saturated, well, there's still some 2x versus 3x versus 4x speed up perhaps that these engineers can get. Here's the setup of our experiment. We're going to gather 16 experienced developers, we'll see just how experienced in a sec, on large, mature, open source repositories. We'll see which repositories in a sec. On average, they're completing something like 16 tasks from their real work. The only way, well, I guess there are really two ways these are selected. One, these are sort of issue-based tasks. So things that require, lots of communication with their colleagues, but ultimately not merging things into main are kind of implicitly excluded. And another is that we ask that if they expect their work to take longer than 4 hours, that they chop the issues up for statistical power reasons to be smaller. But we think they are representative of issue-based work that's forecasted to be less than 4 hours. we're going to randomly assign these tasks, not these developers, these tasks, to AI disallowed or AI allowed. AI disallowed means what you think it means. It means software development in 2019. It means no tab autocomplete. It means no cursor. It means no Claude Code, etc., etc., etc. It means no ChatGPT. AI allowed means what you think it means as well. We're not assigning them to use a particular AI. We're just allowing them to do whatever works for their normal workflows. In practice, we're buying them Cursor Pro, and so they're mostly using Cursor, and they're largely using the frontier models at the time that people would use using Cursor, which is typically 3.5 Sonnet and 3.7 Sonnet, given the period where the study was conducted. And then we're going to record the time to complete each task, both before review and sort of after responding to review. I assume that people here are familiar with the language of merging and PRs and issues. Can I get a hands up if you're unsure about the language of merging PRs issues? Cool. Okay.
Did you give them some time to play with Cursor before the experiment started?
So a tiny bit. They have something like a 30-minute training from us, making sure they can make a change using Cursor agent mode and on their own repositories, and would in principle be able to merge that into their repository. That is it. They are going to be completing, as you see here, 16 issues of something like 2 hours each across the study. So for the later issues, they do have more Cursor experience than early on. A quarter of them have Cursor experience before they start the study. Almost all of them have some sort of regular use of AI in their workflows. Either sort of web-based LLMs like ChatGPT or Claude.ai or something, or they use VS Code or Copilot, which are kind of naturally similar to Cursor. There'll be more to say about this sort of thing in a sec. Okay, here are some of the repositories that we take from. If any of you know anything about open source development, you'll be familiar with a bunch of these repositories. We have the Haskell compiler. That's GHC. We have scikit-learn. We have Hugging Face transformers. On average, these are 1 million lines of code plus. They've existed for 10 plus years. These are large, mature, economically valuable repositories. And these are some stats about some sort of anonymized stats about the developers that we have for each repository. These are typically the third most common contributor by commits to these repositories. So these are some of the really top developers on these valuable repositories, out of somewhere between sort of hundreds to, on the high end, even thousands of total committers. They've been working on this repository for something like 5 years on average. Yeah.
One thing that multiple people I think was asking about during the reading was the knowledge of how LLMs actually work that these people had, because I feel like once you learn more about the theory of LLMs, it changes how you use them. So did you select for that? Did you ask about that? How much ML theory they know and things like that?
Yeah. Maybe let me do some more storytelling. We had worked on this time horizon work. Nate and I, various other people at METR, had some external validity concerns. We thought, let's run a pilot study that will take a small number of months, and let's do it in the most obvious or sort of easiest setting we possibly can. Open source development doesn't require us to partner with a company. And let's get some of the most experienced developers so that we feel that we have high quality people in the study. And then let's just let them cook, and then we'll see at the end what the results look like. We definitely did not select for them being having a lower level of experience with AI tools. We didn't select for them having a higher level of experience with AI tools. Yeah, does that answer the question?
Yeah, I guess. Yeah.
I guess you've seen the graph. I used to when I gave this talk previously. I collect forecasts live from the audience, and there was always an audible gasp when you get to the next slide. After everyone guesses their minus 40% or whatever. Baraz, were you one of the forecasters?
No.
Okay. Also, often when I give this talk, one of the forecasters in the audience, and I get to say, you are this data point.
I would have been more good. Yeah, I would definitely have been on the green side.
So the economics experts, these are professors, these are economists at labs, these are top graduate students. They're predicting something like a 40% decrease in time to completion on these issues. The machine learning experts, these are often people at labs or on the top 4 machine learning PhD programs. They're predicting something like 40% decrease in time to completion. The developers themselves are predicting a 24% decrease in time to completion. The developers themselves, after the study has been completed, retrodicting how much they were sped up in the past on the issues in this study, predicts that they went 20% faster by this measure, and in fact, we observe that they go slower.
That's actually fine for us because we get paid by how much developers think they get paid.
So true.
There are a bunch of caveats at the top here. We're going to go through the caveats. Here's another way of seeing basically the same thing. The developers forecast that if they're allowed to use AI, the issues will take less time, and in fact we see that the issues take more time. Yeah, this is another crazy result. When we first saw this result, to do yet more storytelling, we thought the same thing that you probably thought when you saw this graph for the first time. They've messed something up. And then the weeks go by, and the point estimate is still red. It's still in the negative or positive by this time to completion measure. So we went out watching an ungodly number of videos of these developers working, thinking about sort of all the hypotheses for what might be going on, exit interviewing the developers. And this is what we came up with in terms of factors that we think might be driving results. So first, we have some factors that we think are contributing to slowdown in this setting. One is obvious, over-optimism about AI usefulness. They think it's going to be helpful. They use AI. In principle, they have access to the 0 point at any time by just not using AI. Another is high developer familiarity with the repositories. So in some ways, this is related to the curated context point. Unlike in my own work, often, the developers know how to solve the problem before they start going about solving the problem. They know everything about, well, I'm sure they don't quite know everything about these repositories. They know an enormous amount about these repositories. They know much more than Cursor does about, or the underlying AI tools do, about these repositories. That gives them some sort of advantage. I note this is sort of in some ways similar to the messiness problem that we spoke about previously. These are large and complex environments. There's some sort of preliminary work suggesting that AIs do worse in sort of larger environments by lines of code or numbers of files or something like that. And these repositories are just enormous. The AIs are not so reliable. They're often making sort of directionally correct suggestions, but then given they might be wrong, you both need to verify whether they're right or wrong, and then if they're wrong, you need to redo the work. That obviously comes with a time cost. And I'll skip over to the next one. Okay, here are some factors with unclear effect. I'll skip over most of these, except to talk about, or to at least touch on, below average use of AI tools. This came up a lot in the public conversation around this paper, as some of you might have seen. It's already come up in questions that perhaps these developers are just sort of less capable at using AI. I'm a little bit skeptical of this as an explanation. Maybe now is a good time to talk about why. So I think that the most important reason that I'm skeptical is not reflected on these graphs. It's just that I've used Cursor. I have some extremely talented colleagues. I've watched them use Cursor, and then I've watched many hours of these developers using Cursor, and I'm like, well, are they doing it badly? And I think they're not. I think I'm not seeing these sort of places in their workflows where they have enormous speed improvements that are left on the table. One kind of advanced workflow that probably many of you are familiar with, and some people have pointed to, is the possibility of defining some set of tests that the agent can then iterate against. This is considered, a more advanced workflow that maybe a beginner cursor user wouldn't use. I'm like not seeing, I think, many opportunities for these developers to use those kind of workflows. That's most of what's guiding my sense here. But then also, if we subset to the developers who have, some relevant AI experience before the study, we don't really see any difference in speed up. If we exclude some of the early AI issues, this is speaking to what something like what Boaz mentioned earlier. You might think that they're not so familiar with cursor at the beginning of the study, but like once they're 10 hours through, they do have some familiarity, and they are going to be sped up to some extent. The study is pretty small. This is pretty underpowered evidence, like much of our subsets evidence. Don't take too strong conclusions from this, but we don't obviously see anything jumping out. And then here is coded up the number of total AI hours that these developers have at the point in time when they start a particular issue. That is the sum of time they've spent during the study working on AI allowed issues, and the experience they had with cursor coming into the study. This is quite a conservative measure. There's one developer who's in that last there's one developer who's in that 30 to 50 hours bin, who used cursor as their primary IDE in 2024. They used cursor for 140 hours. To be conservative, they put down I think something like 50 hours. And so they've ended up in this bin. That is in the penultimate bin. There are people who use cursor as their predominant IDE in 2024. I would say already this chart is consistent with like not much going on. Some people have looked at this chart and thought there is something going on from the last data points. That will shrink downwards if you change the coding of this particular developer who's in the penultimate bin. I think the existence of this graph is why we come down on this factor as mixed overall. There's some stuff that seems to point in nothing much changes as they get more experience direction, and some stuff that points in the other direction. Yeah.
So some of the previous points you mentioned that this developers are super familiar with this code base, and that might make it go down rather than go up. Has there been a controlled study where you actually pair a junior developer, maybe just starting in the role with an AI, and see can they first of all achieve the same performance as a senior developer, and is there a benefit compared to a reduction in the speed? Has there been any analysis?
Yeah, great question. We are working on another uplift study now that will have some more junior developers. Previous literature has much more positive estimates of AI speed up. I'm slightly skeptical of many papers in this literature for some different reasons that we can go over. But they are, among other things, using more junior developers and seeing these productivity improvements. It seems totally plausible to me that by the channel that you're pointing at, junior developers will be sped up more. There was another question somewhere. Yeah.
What model were they given any advice on what model to use in Cursor, or was this part of the time when Cursor would auto route to different models? Or?
So we have some data from the video recordings of what models they're using, and they're primarily using 3.5 Sonnet and 3.7 Sonnet, which were the frontier models at the time. They're not given advice about what to use. Indeed, the condition was called AI allowed, not AI must use. They're allowed to use no AI if they want. I think there was one more question somewhere. Yeah.
Did developers need to fix anything that was broken by the edits of the AI agents? I feel like sometimes this happens to me. I was wondering whether this happened in this large code bases experienced developers as well. Did you observe that?
Yeah, totally. One thing that we observe, or one thing that developers report a small fraction of the time is Cursor not being a very mature IDE sometimes breaks in ways that VS Code might not. But the more common thing is that AIs make changes that developers are not happy about. We have here that that developers accept fewer than 44% of AI generations. This is, we think that the proportion of lines when they click accept in cursor is something like 44%. And then we observe sometimes them changing those extra lines, although we don't track that in our code, so we think it's less than 44%. I guess it's more like 20%, 15% of lines of code suggested by cursor are ending up in the final PR.
Yeah, no, the reason I mentioned that is specifically about have the models ever changed code that was unrelated to the task at hand?
Oh, I'm not sure exactly. I guess probably there were lots of anecdotal reports of Sonnet 3.7 in particular doing that kind of behavior. Yep. Yeah.
I was curious, what was the research community reaction to those error bars?
Excellent question. You mean the latter is so close to zero?
No, the other one. Well down the line, but the... about the bucket of developers with hours of experience. Because they all overlap.
Yep, there are like 250 issues in the study. The evidence is, the subset's evidence is underpowered. What can you do? We wanted this to be this like 2-month pilot, and then it ended up being a 6-month project because we spent all this time sort of diving into this crazy result can't be true. Why is it? Are we really sure we haven't messed something up? Yeah. Well, we are doing this larger study, and yeah.
Did you observe any devs just delete cursor and use something else?
I think there was one developer at least who just did not use cursor in the AI allowed condition.
But didn't use it.
I'm not sure about delete.
But didn't use a different AI tool. It's a terrible agent. Like I don't know if you've used it, but cursor, it's like not a very slick agent. So I could see a lot of people wanting to go for different agents.
Yes, I'm not sure what other tooling that developer might have been using. What other AI tooling? I do. Yeah, one.
You'd think that they would gain like at least I don't know, some 5%, 10% just for from the tab autocomplete, like just the baseline. Just not using the agent at all, they would be saving some time.
Yeah. Two intuitions that I have that are not grounded in evidence. You shouldn't believe me, but just like two things to put out there. One, I feel like maybe tab autocomplete is just really underrated. Like the thing that I said previously about the AIs, they don't have much. Actually, I didn't really say this previously. One hypothesis that I have is that the developers are just sort of thinking less hard about the problems when they're allowed to use AI. They just sort of like dump all the relevant information into context and like wait for an output, and then maybe edit that output or something. They're not like in the zone. And tab autocomplete is a little bit more of a in the zone sort of workflow. You're like thinking through the design of the thing and then making a comment like this kind of function goes here or something. I hypothesize that might be a more effective workflow, at least during this time period. Another thing, you didn't quite say this, but a lot of people will say, cursor, it's, this is not my view. Cursor, it sucks. If you only use Claude Code, if you only use Codex, if you only used Sonnet 4, then you would have seen the opposite result. I sat here with these expert forecasters. Some of them are, the developers in this study are extremely talented and experienced, much more so than me. The ML and economics forecasters, even more so. Like some, I'm not going to de-anonymize, but there are some like leaders of the field here. And I sat down with them and I told them about the repositories and I told them about the AI experience or lack thereof that the developers had. Some of them went through scikit-learn issues so they could get more of a sense of the distribution of tasks that these developers were working on. And then they all, well, they don't all give this answer. This is an average, but they pretty much all give answers in the same direction. They knew that they were going to mostly use cursor. They were very wrong. My starting hypothesis is that this is at least it seems not clear to me that this is sort of so sensitive to which tool exactly you use. I think you might need to actually go out there and measure it. Yeah.
Things I'm wondering is like, how, like, I guess this is hard to measure, but in the context of the experiment, how much when they were told that they can use AI was the implication that they should use AI more than they already would?
I think I have a graph about this too. So I think some of them do take it that way, and that's a bit sad for us. But here's the graph. So we asked them in exit interviews what their kind of AI behavior looks like. Some of them using it as they might otherwise. Some of them they haven't misunderstood our instructions and are using it as much as they can, but it's a tool they're using for the first time, and so they're experimenting with it in some sense. And some have interpreted our instructions as using it as much as possible. We see similar slowdown for all groups. But this is very underpowered.
So let's imagine that you did like the following exercise. You took issues from these repositories and made them into a benchmark that basically maybe corresponded to exactly these tasks. And what do you think would be the performance of models, like models we know are good at benchmarks? What do you think will be the performance of these models, and how much would that be correlated with the usefulness for these for these kind of tasks? Like, say, is it the case that basically if you just replace, like I can just imagine by the type of your of the graphs that you say that basically if say Sonnet 3.7 did the X on would have succeeded on X fraction of these tasks, then probably GPT-5 and Sonnet 4.5 would do I don't know X plus 20%, and would that make the difference for these developers?
Yeah, there's this chart from the ARI bench paper, which is another METR paper I worked on, where it shows the distribution in human scores over time, rising from 0 hours to the maximum of 8 hours that they have, and it shows that for a significant fraction of the expert human baseliners, they end up doing worse at 8 hours than models are typically doing at like 2 hours. That is, they could have just deferred to the model at the beginning, and they would have done better. I definitely think so. This bottom point, suboptimal elicitation. It's possible that, in some sense, Cursor is under-eliciting the agents. METR agents eat through a lot of tokens. We think that eating through a lot of tokens using a lot of AI labor is important to getting the best performance out of these agents. Perhaps Cursor isn't doing that to the same extent, and that's harming AI performance. If you benchmarkify these tasks, the AIs would do a lot better. We do have this. We do have some work, which is on the METR research blog, I think, showing that in... I'm going to forget exactly the details, but something like in most cases, when we test agents on these tasks, they're making significant efforts in the correct direction, but a maintainer would not merge in their work. That is, by the scoring standards that we're sort of using here, whether a maintainer will merge in your work or not, they would get 0%. And by algorithmic scoring, sort of SWE-bench-like scoring standards, that they would do quite a bit better than that. Quantitatively, my sense is that at the current frontier, maybe you should drop off like 20% or something from SWE-bench scores to get sort of SWE-bench scores if the task was to merge into main. That's based off of work that's not currently published.
So basically, like if I get you correct, like you think eventually, as the models, as the model gets better, they would basically get to the point where the developers could have just asked the model to solve the issue, and the model would solve it, but there is a tax on actually solving in a mergeable condition, and maybe some messiness tax, and that tax might be something like 20 points.
I think that is part of my model. on a previous slide that I saw of yours to this class, there's like the meter graph, except maybe the meter graph's going to go super exponential, or maybe it's going to go sub-exponential or something. I think there's like another version of this graph which is like time horizon, except like imagine it really refers to the thing that we care about. Maybe the thing we care about is merging into main. Maybe it's something else. It's not just this sort of crude summary statistic, low context baseliners, zero marginal cost scoring, blah 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 blah. It's plausible. My best guess null hypothesis is that, like on a previous graph we saw, the slope of all these time horizon graphs, it's roughly the same, but the intercepts can be very different. And so the intercept using, high context humans and messier tasks and these like more challenging mergeability conditions and so on, shift the intercept downwards, but we still see similar slope of progress. I don't know that to be true. It's plausible to me that we see on when thinking from the perspective of algorithmic scoring, this like straight line exponential progress, but for something that brings in extra notions of quality or something, we see some curving off. I think that's a big question.
The question over there.
Yeah.
Are you guys thinking of like kind of doing something like that, where you're like combining the time horizon graph idea with this, where it's like instead of just having your baseline like time per human, it's like the 2024 line is like the human who has access to like the best 2024 model, and like because I'd imagine you could maybe kind of see kind of a slowdown and then like an increase when like if a model is like better at like following your like preference style of coding, because like I'd imagine if I was like a good dev, which I am not, like I'd have like very strong preferences, and so like I like to just like auto accept everything.
Yeah.
But they would just see something that maybe if they auto accepted everything it would work, but like it's very ugly and like doesn't fit with their vibe, and so they like reject it and like something like that.
Yeah. We're both going to produce, just this graph, except it's only the last data point, and it's like over time, we're well powered to do sort of month by month by month. We'll see how that trend goes. And the main meter graph, I don't know, the time horizon graph, except it's on tasks like these, and success is judged by human. Here are some caveats to what you just seen with the. There were a couple of people, I think, with questions before we move back to lecture. I'll stick around for a little bit afterwards, if you want to. If you want to chat. Here are some caveats to the work that we've just seen. First, we provide evidence for a particular set of software developers working on a particular set of tasks. The setting is weird. It's really weird. It's really interesting. It's interesting for the same reasons as the reasons it's weird. The code bases are enormous, long-lived. The developer's extremely experienced, so on and so forth. Perhaps we'd expect to see very different outcomes in different settings. I would say that, I and probably you and, our expert forecasters expected to see one thing in this setting and they did not see it. I think the jury's out on whether we'd see it in different settings. Maybe that sounds like an insane thing to say, but I do think it'd be helpful to actually go out and measure these things. The second is, we saw that progress in AI has been pretty rapid. Many of you would have felt that in your own lives. Perhaps we'd already see a different result if we'd measure this today. We are in fact continuing to do this uplift experiment, and Nate will shout at me if I reveal the current outcomes that we're seeing. Anyway, AI has progressed since then. Maybe today we see speed up. If not, perhaps we'll see speed up in future. This is a very dynamic situation. And maybe with reference to some of these things, Boaz asked me to touch on, which of these things might change as we move into the future. Surely low AI reliability will change. Surely grabbing the correct context will change as more people do. At the moment, quite rudimentary things like adding cursor rules, but perhaps there'll be more things of that ilk later that allow AIs to better use context. Maybe it will have sort of observed more of your past work and be able to integrate that. The developers will be more experienced using AI tools. To the extent you think that's an important channel, that will probably be different in the future. There are a couple of things here that would be different. Latency also for at least a given level of capabilities. I think we expect the AIs to be faster. Maybe that won't be realized because we'll want to go with the more performance capabilities. But it's possible that the AIs will speed up that way. Suboptimal elicitation. Presumably these agents at least could get better elicited by by current or future tools. Perhaps your favorite tool that's not Cursor is doing that today. Perhaps Cursor is doing that today. What are the takeaways I have? First, at the time when we set off doing this study, we had another project, which was to survey AI researchers in great detail about the degree to which they think they're sped up by AI tools today. I think we were going to have them go through a kind of time tracking exercise and sort of really carefully reason about this question. A lot of people have this intuition that maybe one good measure of AI R&D capabilities explosions would be to ask machine learning researchers the degree to which they think or engineers, the degree to which they think their work is being sped up by access to AIs. I think a straightforward implication of the work we've seen is that those surveys might not be reliable. We don't have strong reason to think they're reliable. Maybe forecasters will update after seeing this evidence that they're too, or developers will update that they're too optimistic, and so forecasts will be better in future. Or it's not. I'm not necessarily saying surveys are always rubbish. I will say that, especially in the exit interviews, these developers are in ideal conditions, or they're in very good conditions to guess the degree of speed up that they had or didn't have. They have, from all of their past work, the time it took them to complete each issue. They made notes on where AI was more or less helpful for each issue. They've noted whether this was the kind of issue that required a lot of external to the repository knowledge or not. Loads and loads of things that I think would suggest they might make better predictions than otherwise. And then the second takeaway, this is often a takeaway from AI papers, benchmarks don't tell the full story. Here the picture is maybe something about mergeability and quality versus algorithmic scoring. Maybe it's something around integration between AI tools and developers. Maybe it's something around messiness of the task distribution. Benchmarks look very bullish. This RCT looks much less bullish. Now, here's another source of field evidence. These categories aren't very clean. I'm not exactly sure what to call it. I'm calling the benchmark style evidence benchmark style, or sort of experimental or like lab-like evidence, and things that look like RCTs or labor market data I'm calling field evidence. The stuff from the field is messier. It's can in many cases be smaller. It can be sort of hard to interpret, consistent with many things. It's also maybe closer to things you care about than the lab-like conditions. I originally come from academic economics, which has this field versus lab distinction that feels kind of similar. Here's some labor market data. A lot of papers are doing something similar to the exercise that we're about to see, but just pointing to this one. So you might know about these exposure measures that OpenAI and Anthropic have put out. The OpenAI one looks something like this. For each ONET task, that is, ONET is a database I think published by the Department of Labor in this country that details something like 10,000 tasks, or maybe it's tasks for 10,000 occupations. I can't quite remember. That are representative of the kind of work that's completed in the US economy. For each task, these authors of this 2023 paper are going to ask, can GPT-4 or GPT-4 plus some extra software plausibly reduce the time to complete this task by 50% or more? And then the occupation score is the average of these scores for the tasks that make up that occupation. So if you had 50% ones or yeses and 50% zeros for a particular occupation, you'd end up with a score of 50% on this measure. We might ask, have people moved into or out of more exposed occupations? Occupations like software engineering, perhaps highly exposed. Occupations like hairdresser, perhaps low exposure. The answer, it seems, is no, at least on first blush. A lot of the other papers in this literature, often similarly using this CPS dataset, are coming to broadly similar conclusions. I'm going to go quickly through this because I think you have a speaker that will present on this soon. One of a number of papers that find some positive effect in some sense in this literature, these more recent papers, is called Canaries in the Coal Mine, Brynjolfsson et al. The CPS data, as I mentioned, is pretty small. In particular, it's maybe too small to reliably estimate correlations within small cells. So if you subset to sort of very junior workers or something, then you end up with even smaller data, and then it's harder to distinguish answers to hypotheses. But at the same time, we maybe are more interested in entry-level hiring in particular. I think that's where much of the public debate has focused on. This paper is going to use large-scale payroll records and present descriptive stats, not causal estimates from that data. They have the paper is centered around 6 facts. I'm not going to go through all the 6 facts. I'm in particular going to go through this plot, which I think says quite a lot. What are some things I want to point to? First, they are only seeing declines in employment, or growth of employment. Sorry, for young workers going into industries that are highly exposed by this OpenAI measure to AI. And everywhere else, they're seeing kind of robust employment growth. That is both for more experienced workers working in AI-exposed occupations. They're seeing pretty robust employment growth. For young people working in less AI-exposed occupations, they're seeing pretty robust performance growth. I would describe this as maybe less pointing to unemployment effects of AI and more there has been in recent times in the US robust employment growth in sort of all groups, at least by this aggregation, except for 22 to 25-year-olds. Apologies. Going into industries.
That's okay. Many of them are under 22.
Going into industries that are highly exposed to AI.
It's a U-curve.
There's this great Joshua Gans, who's an economics professor, Substack post about this paper that I really like. It suggests something like this. This is speculative. This is roughly how I'm integrating this evidence into my model of the world. More work is needed, as always. You might think that. To some extent, you guys, or at least, typical 22 to 25-year-olds, have something like textbook-like knowledge from their education, whilst senior, I guess maybe I'm a senior worker now. Senior workers have tacit knowledge. They've worked on the job. They have more experience working in teams on large code bases. In the software engineering context and analogous things in other contexts. Perhaps in the economic jargon, AI is a substitute for textbook-like knowledge. That is, you can ask GPT-5 or your favorite AI model textbook-like questions, and it answers pretty well. It has answered pretty well for a long time. The LSAT is saturated, but maybe it's a complement for tacit knowledge. That is, if you know the right things to ask, or if you're sort of able to do the kinds of tasks that AIs are less strong at, or something, AI might benefit you. This would be compatible with the picture that we just saw, where even for people in AI-exposed industries who are more senior, we're seeing this robust employment growth. One concern that Gans points to is perhaps the education system creates graduates that in order to be maybe gainfully employed is too low a bar. Ideally, graduates would have this sort of tacit knowledge that's complementary to AI, at least on this framework, so that they could work productively with AI in their jobs. But it will be difficult to find opportunities to obtain this. Perhaps in principle that's true at universities, probably not. The main thing that I think he's thinking of is that firms might not be willing to offer this kind of on-the-job training that won't be profitable to them because the rest of the market captures it in some sense. It's not firm-specific training. It's sort of giving them general capabilities that they can apply to any old firm. I think this is a classic economics problem between on-the-job training that's more general versus firm-specific. There are some other papers in this literature that are consistent with this result. There are these 3 papers finding broadly similar things. One of them is in I won't go through these papers. And then there's this one paper that's doing a slightly different exercise in Denmark and seems to contradict the results from the canaries in the coal mine paper. I think I'm unsure if this is a difference in the institutional setup of Denmark versus the United States, or if this is about them doing a slightly different thing, where they are, instead of this sort of GPT-4 AI exposure measure, they're they're looking for which Danish firms mention in their job listings. No, sorry, this is not true. They have surveys of the workers at Danish firms asking if those firms have encouraged them to use AI, and that's the thing that they're using as their sort of exposure measure, quote unquote. Stepping back, what's this field of evidence tell us? I have missed out on. Actually, let me go to this table first. So here's some other literature on sort of productivity RCTs. It finds broadly positive effects where we found negative effects. I've skipped over that, and I'm calling the field experiment evidence kind of bearish despite these papers. Why am I saying that? One is for many of these papers, I think they're using outcome measures that that I don't have a huge amount of faith in. Things like lines of code or like number of PRs or something. I'm sure many of you already have this sense, but when I talk to journalists, an analogy that I draw is with producing articles using LLMs versus not. Maybe using LLMs allows you to produce a higher word count article, but that's not really what you care about. If anything, cogency might be attractive. Here I'm thinking we're using a outcome measure for our work that feels closer to the thing that's economically meaningful, although I still think leaves some stuff to be desired. We're using these more experienced developers. We're using these non-synthetic tasks. So for a lot of these studies, they're using tasks like implement an HTTP server. These kinds of tasks that AIs are sort of preferentially good at that I think don't really come up in economically valuable work. That makes me sort of less interested in their conclusions from an external validity basis. Anyway, I'm going to take it as given that we're focusing on this METR RCT as the field evidence on this question. And what have we learned from all this? If we restrict to this RCT and then broadly the labour market evidence, I think we're finding that the productivity impacts here are not obviously large. At least they're not obviously large yet. The employment impacts are nascent. And they are highly concentrated. To the extent that we're seeing economic impacts so far, it's just for these very young people in very AI-exposed industries. This suggests a puzzle. On the one hand, we have the more bullish evidence, the more benchmark-style evidence, the impressive time horizons, or you could sub in benchmark scores that models like 3.7s on it, 3.6 on it, and then the latest round of models have. On the other hand, we have AI slowing down developers and limited labour market impacts. What's up with that? How do we reconcile these things? The reconciliation, I think, is going to be similar whether we're thinking about this kind of labour market style evidence or this RCT style evidence, but I'll focus on the more RCT style evidence. One possibility is we cocked up. We go through in the paper all these documenting all these ways we think we might have cocked up and seeing if that's borne out by the evidence or it's not. Some of them we find hard to classify. Some of them we rule out. I still think this is a possibility. Maybe the developers are not using AI as best they could. Maybe scope is increasing. One possibility is it's easy to add yet another test when you're using AI versus when you're not, because that's something that AIs are relatively better at. And so the PRs when AI is allowed are longer. In particular, they're higher quality in some sense. They have an extra unit test that's desirable versus if AI was not allowed. And that's what we're picking up on when we show that these developers take more time when AI is allowed versus not. Another possibility is these tasks are weird, the developers are weird. One thing that economists are often concerned about is that we're paying these developers by the hour rather than per task, so they don't have incentives to finish quickly. That was an intentional decision at the time. We were, remember, we were concerned about this external validity stuff coming out of the time horizon work. We wanted these maximally realistic tasks that would really come up in the work of these developers, and we feared that if we paid them per task, they'd be incentivized to give us tasks that were smaller, so they could be paid more often, and then they would not be these sort of real in the wild tasks. That's the design trade-off. I agree it makes interpretation more challenging. I'd be interested in doing it with incentivized times later. maybe we'd get a different conclusion if we did that. Although it would have other types of interpretation issues, given it's not the task distribution that we care about. Another that I think is very important, should be front of mind for myself and for all of you guys. This is a small study. Small studies, even if ex post they're statistically significant, should not give you so much evidence against your prior. I think we can work through this exercise, but I think quantitatively, if you had something like a 5% belief in negative productivity beforehand, and you see this kind of evidence, you should update to something like 25% chance that this is negative. Of course, I think this is stronger evidence against, not zero, but like very strongly positive productivity improvements. But anyway, that's important. There was one question at the back.
So for the idea that you shouldn't be paying people by the hour, are they getting paid both to do the non-AI tasks and the AI tasks, no matter whether they're assigned to either of those? So aren't they incentivized to do badly in both?
Yes, I agree. It's not obviously a differential. It's not obviously a differential concern. Another concern that people bring up is these Hawthorne effects, where perhaps because you're in an experiment, this relates to an earlier question, you act differently. In this case, even more so because your screen is being recorded. Maybe you act differently to if you're developing normally. Again, it's in that case, it's not clear it has this differential impact.
There's another question.
Yeah.
I was curious, and I think some other people were, about the cheating. So I'm assuming that the cheating was using AI during the disallowed AI. Why would what would be the point of some dev cheating that way? And also, what did you see? How did you find that?
Yeah. I mean, if they believe that they're going to go quicker when they use AI, and they want to go quicker for reasons other than us paying them, they can move on to the next work or something, then they might want to complete the task in a quicker time. If they think that we're not observing them, then they can get away with that. They'll want to cheat. I guess that's the thought. Empirically, it does not come up very often. The way that we verify that is with these screen recordings that we have of the developers. We don't have labeled screen recordings for all of the issues, but we have some. Oh, excuse me. We have some subsets in the paper where we recode those cheating issues to AI allowed rather than AI disallowed, or we, I think, remove all developers that have ever cheated. It does come up very rarely. Yeah.
This is just out of curiosity, but in the paper it said one person cheated by accident. I was just wondering how it's possible to cheat using AI by accident.
You've got all the things on your computer. You forget which condition you're in.
Fair enough, I guess.
I think that's it. It's possible I'm wrong on that. It's possible they forgot to turn off tab autocomplete on VS Code or something. I'm not exactly sure. Yeah.
I mean, every time you go into Google and you search something, right?
Yeah. They were allowed to use Google, and that's
minimus AI use.
Yeah. Good point.
In March, Google was still telling them to eat rocks, I think.
That's why we see sold out.
Cool. So here are a couple of ways of resolving this puzzle, perhaps that do not look like we messed up as the explanation. One is maybe there's no puzzle. We saw earlier that we were using 50% time horizon, but maybe 50% time horizon isn't that interesting. Maybe we care about. That's a different point. Reliability needs to be very high to save time. Maybe you need 80% time horizon is the relevant thing. The 80% time horizons are much lower. They're something like a factor of 5 lower, I think. And so the AIs are just not at the capability level where they can reliably do the kinds of tasks, taking humans the kinds of time that we see here, something like 2 hours on average. Relatedly, the average task length, I think, is actually 2 hours, not 1.5 hours in this RCT. That's above the 50% reliability point. Maybe there's no puzzle because even by 50% time horizons for the models that were frontier at the time of this study, they're not capable of typical tasks. Perhaps, as mentioned from Boaz's question earlier, the AIs would pass sweet bench-like scoring. And so matching time horizon in some sense, even though they fail on this mergeability criteria, we have some work suggesting this is that there's something to this directionally. Another possibility is low versus high context baseliners. Another model that I have that's not obviously well evidenced, but maybe will be helpful to pass along, is that all time horizon versus calendar time relationships are like roughly exponential in this way, and we can debate intercepts. But if you name your factor that suggests that we care about something different to 50% time horizon for low context baseliners on zero marginal cost scoring, I will reply to you, well, that's just like 2 doublings off. That's just 1 doubling off. That's just part of the intercept off. Maybe instead of here us using low context baseliners, that is people who are not already intimately familiar with the kinds of tasks that they're working with. They are experts in some sense in the domain, but they haven't seen exactly the kinds of tasks that they do as part of this study. Whereas in the developer productivity RCT, they've worked in these repositories for many years. They have much higher familiarity. Perhaps the high context baseliners, they'd be doing all the work much quicker, and so we'd see this drop in intercept. Implicitly, the time horizon would be lower, and then it wouldn't be so surprising, perhaps, that the AIs were doing poorly in the developer productivity RCT.
So one version of this would basically say that if these tasks took 2 hours to these high context baseliners, maybe these are actually 4-hour tasks for
16-hour.
Yeah, and then it's not surprising that models are not very good at those, but it's just a matter of wait 7 months and that's it.
Yeah. Maybe task distribution is the next thing. So perhaps if we measured, if we went about our RCT on very meta-style tasks, we'd end up with an answer that looks not out of place with the benchmark style results. Time horizon and uplift in some intuitive sense would appear more congruent. But perhaps the difference is entirely explained by task distribution. If instead we went about doing the time horizon graph analysis on tasks like this, we'd see something much less impressive. And then lastly, we've already gone over this. Maybe the agents inside of Cursor or inside of the tools that developers are using are, in some sense, under-elicited. They'd get more power out of them if they were churning through more tokens, perhaps with parallel agent calls, or perhaps by bringing more into context. Various ways you could go about this. Yeah.
When you look at your main plot of the time horizon trajectory going upwards, do you think carefully about sort of the tooling that's being used? I mean, maybe it's not an issue at this point, but certainly when you start looking at 40-hour length tasks, right, there's probably some tool calling that is at least highly useful for an AI model to use.
Yeah. If you look in the paper, you can see the kind of agent scaffolds that are applied on top of these models. They have access to a bunch of bash commands or tool use. I agree. Scaffolding is an important question, or elicitation more broadly. If we include possible fine tuning or other types of things, is an important question. A lot of work has happened at METR going into that question. The scaffolds that we've ended up with using are quite simple. They're quite, for non-reasoning models, they're often React-like, if you're familiar with the React framework, or for the reasoning models. I think, I can't remember exactly the details, but they use a different kind of scaffold. We developed these scaffolds on dev sets, that is not train sets in the normal sense, we're not training the model on this scaffold or something, but on a held out set of tasks, we try and get to the best possible performance we can or something, and then we measure performance with AIs in those scaffolds on sets of tasks that we've not developed the scaffolds on. I think if you were using worse scaffolds, we'd see worse performance there. It's plausible there's even more gains on the table. We had originally wanted to produce estimates of maximum capabilities, not average sense capabilities. And so we felt very sensitive to these kind of scaffold questions. I think in the end we've done the best we could. Maybe I should give an anecdote about. There's this kernel bench blog post that METR has, where an ex-colleague of mine, Tao, shows that he can get dramatically better performance on this compute kernels benchmark than the state of the art at the time by a basically better scaffolding tricks. And in fact, the performance he achieved is better than the various performance estimates that have come from, I think, even more advanced models after that blog post was published. There can be a lot of juice in scaffolds. Okay, implications for technological unemployment. Here are some possibilities for early 2025 AI. Perhaps it doesn't boost productivity, and we shouldn't think that technological unemployment is immediately around the corner. Perhaps it does boost productivity, but there's a bank tellers-like story for those of you. I'm sure many of you who have heard that. Perhaps it's a complement for at least some types of human capital, such that we shouldn't expect technological unemployment from near future capabilities. Maybe it just hasn't had time to diffuse through the economy. This is a little bit of an old survey estimate, but certainly AI usage has not fully diffused through the economy. I'm sure the kinds of AI workflows that you guys are using or that I might be using have not fully diffused through the economy. Maybe that's what's explaining the small employment effects that we see. And here are some implications for automated R&D. The first thing to say is that extraordinary things happening with automated R&D is, in principle, I think, compatible with small economic impacts. In fact, many of the stories that the AI 2027 people are wanting to tell involve internal deployment, that is, frontier AIs that are not even released to the public, let alone the public being able to properly integrate them and into their workflows and diffuse them throughout the economy. We could either via that channel or via standard diffusion stories, just people are not using the AIs as best they could possibly be used, see smaller impacts throughout the economy than we see internally. One straightforward implication, I think, is that the economic evidence and the RCT evidence provides negative evidence in levels for at least capabilities on some types of problems in some conditions. Maybe the trend is exactly the same, but the trend on the thing we care about is some shift downwards in the previous language that we looked at. I think Kokotilo saw this evidence and mentioned that he'd had some updates to his timelines in light of the productivity RCT. One reason why you might think that even there exist settings where productivity gains are much smaller might be important is that you might have a view that capability explosions are only going to happen if you close the loop on AR&D, and so having even one important type of problem where where we don't see models being highly performant would seem to be evidence against explosions, or at least against the timing of explosions. Looking beyond this, and coming back a little bit to the reconciliation point, maybe the field-like evidence underestimates capabilities for some of the reasons that we looked at previously. Maybe we should have the same beliefs about automated AR&D as we did before seeing this study. It's all explained by poor elicitation or something like that. Perhaps the other thing is true, and there's something weird about taskifying. There's something weird about benchmark style tasks, and we should update more strongly in the direction of this RCT and of the labour market evidence of AI capabilities not being so strong today. Another possibility is just it's complicated. Different things are true in different settings. Here's a big question which came up with some of you in the break. Is the discrepancy that we see, to the extent that it's not about differing task distributions or something like that, is the discrepancy we see only in levels? That is, should the updates that I make only be a shift downwards on that time horizon graph as a null hypothesis, or is there something deeper? Is there something that would affect the trend? Is there something like we might see time horizon continue to go up exponentially, and yet speed up curves off or goes not sublinearly but sub exponentially. Perhaps this is because you're hitting some sort of communication bottlenecks between the AIs or between humans and the AIs or something. And so even though you've solved all the problems in some sense, you're not reaching these really great speed ups. But perhaps even the opposite is true. I think this is a huge question. I don't know the answer to this question. Other than that, thank you very much for listening. Any more questions? Yeah.
Going back to the GDP Val paper, which I know you said you didn't know as well. So no worries if this isn't something you have thoughts on. But one of the most shocking charts from that was the one saying that the AI was basically worse at straight prose tasks than things that were Excel outputs, for example. I'm curious if you had any perspectives on why that might have been.
Pure speculation. The vibes I get from Twitter or something, the anecdotes that we see in the wild points to major AI companies focusing on coding problems and more technical problems in the recent past. Meanwhile, people who I consider good writers have lots of complaints about the writing of frontier AIs, and they have those same complaints. A year ago, 2 years ago, perhaps we've seen much sharper progress in technical problems than we've seen in creative problems. I'm not sure there's anything about that need be true in principle or something, as opposed to just being a focus of a contingent focus of the companies in the recent past. Maybe it is more fundamental. There's one more. Yeah.
Would you mind just going over quickly your last, big closing point, which was in levels? We didn't quite understand what you meant by in levels.
Yeah, I mean, let's go over here. So we have this time horizon trend, except, imagine it's not quite the time horizon trend, okay? It looks like that, but here is thing we care about. Maybe time horizon is the thing we care about. I suggest maybe it's not. Maybe it's not the thing we care about. But there's something we care about, and it's going up like this, or at least time horizon. Time horizon is going up like this. Maybe this axis actually refers to multiple things, and I'm a bit confused. Maybe this is the time horizon trend. Sorry, but the thing we care about instead is going like this. So we continue to measure that. Maybe originally we had a time horizon trend that looked like that, and we had this. And the truth is, we just have this difference in levels where when you adjust for the task distribution, when you adjust for the cost of scoring, and when you adjust for high context baseliners and adjust for reliability, so on and so forth, you just have this straightforward shift. Perhaps that's not the case. Perhaps you see different behavior on the thing you really care about versus time horizon. I consider that an open question. Yep.
For the developer paper, how did the developers themselves kind of reconcile feeling like their workflow was sped up, but at the same time, the result was not that? I'm wondering, looking at the graph where you kind of graphed how developers were spending their time, and they were a little more idle, and they also spent some time, less time looking for stuff like researching. So I'm wondering, did they feel because they had to do less work mentally, that maybe, did they consider the work that the AI was doing part of their workflow and time that they spend working?
Yep. Sorry for plugging my Twitter, but I'm not sure where else you'll find this. Several of the developers, after the study has come out, have de-anonymized themselves with these blog posts about their experience. The blog posts are supremely informative. I strongly encourage you look for them. I've retweeted many of them. Yeah, and I want to say again, the developers are so talented. They are, an important part of the story here is they are so much more talented than me. They're so much more talented than sort of many software developers. Yeah, as far as how they reconcile things in their own mind, I think I rarely hear them point to this more idle time. So here, idle time is referring to sort of time they're not doing anything that's not related to waiting for the AI to produce some output. I think I don't often see this. My sense is this is probably just noise. They do mention sort of, I'm not sure peculiarities is the right word, but let's use that. Peculiarities in the workflow where they do need to sort of spend this time waiting for the AI output and then potentially needing to edit that output, and those are a bunch of high latency steps. A lot of the stuff they point to looks like places where the AI is just not so performant on the kinds of problems that they work on. One of the developer threads points to, or maybe I'll say this from the perspective of my own experience. Before this study, an experience that was very salient to me is, the occasional time when cursor 0 shots, some problem that I consider kind of hard, challenging for me, is going to take me like 2.5 hours or something, and all of a sudden the solution is there. I'm like, wow, magic! The machine god is with us now. And now a aspect of the workflow that's more salient to me is the many times when I go through sort of 5 conversation turns or something with Cursor or with your favorites AI tooling, and then it turns out it's not quite what I want. Like actually, it's not been designed in quite the right way at the beginning, or we've just sort of gone down a path where the AI is no longer being coherent in some sense, or I just want to like press the slot machine again. One of the developers has this thread where he compares getting AI outputs to pressing the slot machine again. I'm not saying that. I don't want to make claims about how important that is versus the times when you get this impressive 0-shot performance. But I'll say that to the developers trying to reconcile their forecast versus the observed, to myself thinking about my own work, these examples on the negative side have become more salient than they were before. Yeah.
So my classmates and I worked on the recursive self-improvement experiment for this class, and one thing that we realized while working on this was on things like, for example, MLE bench and everything, we see like a large increase in multi-agent systems being able to complete these tasks faster and faster. And there exists like a different scaling law, I guess, for like what these models can achieve given that everything, perhaps including fine-tuning as well, for things like ASTA bench, for example, by the Allen Institute. So do you have you looked into like the scaling laws for the best performance that we can get from these models? Because it feels as if we're going to get like the loop closed before any single frontier model is actually able to close the loop itself, if that makes sense, right? Maybe like some sort of specialized team of frontier agents is going to be closing the loop, and it feels like the forecasting that we're doing while only looking at single frontier model performance is kind of lackluster in that sense.
Yeah, I don't. I'm not sure how closely I can speak to that. There is a figure, I think, in the time horizon work that shows that the performance of these models, or the difference in performance from what you might expect on average or something of these models is highly correlated from GPT-4 onwards. So my understanding is that the capability profiles of models from the different providers, or conditional on like the first principal components of their capabilities or something, models within providers that are more or less advanced from each other, those capability profiles have like similar shape. And so I don't, on that very weak basis, share the intuition that the holes that some models have in their capability profile are going to be made up for by other models. But I'd be curious to personally dig into more the kind of thing that you're pointing at.
Okay.
Yeah.
You said this like earlier, and I've been like thinking about it. Like the idea of like when you use AI, like your general focus level goes down a little bit. So like I remember reading like literature on like focus. It's like as soon as you get distracted, like it takes you 15 minutes to switch back. And I know like every time I use Cursor and it takes a while, I just start like scrolling Twitter. The second I go back, I'm like, I don't even know what I'm doing.
Yeah.
So, I mean, my guess is because they were being recorded, they were not scrolling Twitter in front of you. But like, it wouldn't shock me if like, they were waiting and then they just like started thinking about what they were going to make for dinner, and then they saw it, and then like that like decreased their productivity. And then it also kind of explains this like why they think it took like less long than it did, because like if you're kind of like idly thinking about something else, a lot of times it seems like these things go faster. So like I've like had something I need to code, and then it's like, I don't know, 4 p.m. and then I finish it, I'm like, oh nice, that was like 45 minutes, then it's dark inside, I'm like, oh shit. So like I feel like maybe that could somewhat explain it.
I think it's Buzz mentioned earlier, possibly AI companies, AI tooling companies are producing benefits for the developer experience more than productivity benefits at recent margins. I don't want to make strong claims about that, but it seems somewhat plausible to me. Yeah.
Actually, like, are the developers are in touch with them? Are they using AI? Like, you're basically.
Oh yeah. We buy them their Cursor Pro subscriptions, right? And so we see, and then we forgot to cancel their Cursor Pro subscription. So we see whether they continue using Cursor after the experiment. And I can't remember exactly the fraction, but it's very, very high. My co-author Nate is from the like SaaS startup world or something. He has some sense that like if you're 50% of your customers are continuing to use your products many months afterwards, that's like stupendous. This is the best product that's ever happened. My sense was it was something like 80% of developers are still using Cursor most days, something like 2 months after the experiment.
So you prove it to them that it slows them down, and they still use it.
Proof is strong. Proof is strong. Some of them have the view, people in the public discussion, that this won't be true for next generation models. I think the jury's out on that, but perhaps they continue to have these optimistic expectations because something about the underlying evidence has changed.
So the study was a gateway drug. You got them addicted.
I mean, some of them would have used Cursor over that 6-month period for the first time, regardless. But perhaps there's some of that going on. Yeah.
Are you aware you're still monitoring their cursor?
We're continuing the experiments with the same developers, so they're now still involved in the experiment. But there was some period where that wasn't true. Yeah.
I'm just still surprised that there weren't any like Claude Code or Code exploits among your dev pool. But like nobody was like, I want to use a different agent.
Is it the case that no one uses Claude Code? I'm not sure it's the case that no one uses Claude Code. I think we'd have statistics on this in the paper. This is slightly unrelated. I consider the fact that they weren't using AI before to be some evidence in favor of AI not having large productivity effects. That presumably it would be the case, or more likely to be the case, if it did have large productivity effects for this kind of person, that their friends would be telling them like they've got to use this AI tool, and then they'd adopt it. Anyway, I think it's not the case these people are using Claude Code. We're continuing to run the experiments. The condition continues to be AI allowed. If they want to use Claude Code, they are very welcome to use Claude Code. And we're paying for their tools more flexibly this time around. So if costs were a concern, which I think it probably shouldn't have been, but if costs were a concern, then that would be covered.
So basically, now like the new condition, it's pretty easy for them if they want to use like some code like CLI agent, they can.
Yep. It was true in principle this time around, but yeah. Yeah, any more? Cool, thank you very much.
So originally I thought I'll talk a little bit about kind of frontier kind of responsible scaling policies or / preparedness framework, etc. But I think just moving to a completely different topic right now, I'll find some time to talk about this, and so let's just stop here, but I'll hang around for basically office hours, and I think Joel also will hang around, so